when you combine the different modules of the software, you will be able to understand the connection better. Operating procedure is the step-by-step guide that a person needs to do when it comes to execution of the program. So at the end of the day, you need to see that whether the software meets the needs of the user. Amount of skill, talent, technology that we have, how can we build a model that will suit to the requirements of the project? Good morning and welcome to the first session in Unit 1, 5th semester B.Ca, Software Engineering, where we are going to talk about software process models. Now, it's quite interesting for all of us to understand why software engineering has become such an important subject for the B.Ca as well as in the modern project management cycles. So software is basically a set of instructions in the form of programs to govern the computer system and to process the hardware components. To produce a software as a product is a set of activities that is used in, and this set is called as the software process. So basically, a software is designed in such a manner which has got a set of instructions which are predominantly made in order to get an objective or a result. So that's exactly where this software process comes into picture, where you would try to understand that if I want to build a model, if I want to solve a purpose, an objective, I would try to build in a set of instructions which would give me the desired results. Followed by which, what are these software processes? Software processes in software engineering refer to the methods and techniques used to develop and maintain software. Now let's focus on this word methods and techniques, because using different methods and techniques, you would be able to develop a better software here. Now some of the examples of software process which we would be talking about is the waterfall model, the spiral model, the agile model. So there are many models that's going to come in. But before we enter into the software process models, we need to understand this methods and techniques word. Why? Because this is not something which is done randomly. This is done with a purpose in mind. This is done with the ideology that yes, we have to solve a problem using a particular method, and there is some client requirements that we need to meet, and with the existing amount of skill, talent, technology that we have, how can we build a model that will suit to the requirements of the project? Now moving further, let's try to understand the first one called as the waterfall model. Now, the waterfall model is a linear sequential approach to software development. So when I say a waterfall model, it would be something like this, just falling down, cascading down like a waterfall here. The moment you look into it, it says it's a linear sequential approach. So which means it goes in a sequence. One by one, we need to take up the model. One by one, we need to take up the steps here with distinct phases such as requirements gathering, design, implementation, testing, and maintenance. Now, this is very, very important for us to understand. When we are talking about sequence here, that means there is a set of activities which needs to be completed before we move to the second step. Now, the sequence is designed in such a manner that every activity will have some meaning, will have some objective which has to be cleared, and then only we can move to the second step altogether. Now, in a waterfall, what happens is that as you start moving through the project, as you start advancing yourself in the project, you will understand that every stage will have a set of objectives which has to match the previous as well as the next step. So automatically what will happen is that when you combine the different modules of the software, you will be able to understand the connection better. So a waterfall model actually creates a link between the previous and the next step, so that for the software developer, he understands in what sequence are we working to complete the task. Followed by which we have another method called as the agile method. The agile is a flexible, iterative approach to software development. Let me again reuse this word. flexible, iterative. When I use the word iterative, that means again and again. I can keep changing, I can keep adding up, I can keep improvising the entire program. Now, the first part, flexible. The word flexible is very important in software development because as the client requirement changes, or if there are going to be any additional tasks that is going to be presented, you need to take it and you need to add it to the existing project. You cannot go on a rigid, a watertight compartment trying to say that this is the only thing that we can develop. Rather, you need to have a software development process that can accommodate changes and that can build in a robust model which can address the needs of the client at any point of time. Now, going further, when you look into this software development project, it has got an emphasis on rapid prototyping and continuous delivery. Now, this word, the rapid prototyping and continuous delivery, is an important key term that you need to understand. Why? Now, when you want to build models quickly, when you want the deployment of those models in your system, in your customer's arena altogether, that means you should have a rapid prototyping. The scaling needs to be much more faster. So that's where an agile development model comes into picture. Why? Because you will have the capacity to scale yourself up. You will have the ability to build processes better than anybody else. Followed by continuous delivery, which means to say that at any given point of time, you can continue the process. You will be online in terms of delivery. It is not something like a stopgap arrangement, but it is a flow. You can see that at any given point of time, 365 days round the year, you are able to deliver the project to the client on delivery, on request, on command. So that's exactly where you would see that the agile software methods is coming into picture. Followed by which there are three main components of the software that we are going to learn, starting with the word called as program. Then we will go into documentation, and then we will get into the operating procedure. Now, all these three words are very important. As a part of this module syllabus, we need to understand that in software engineering as a subject, you need to understand the terms and terminologies clearly because that will define your activity. Now, the first thing, program. A computer program is a list of instructions that tell computers to do. I mean, what it needs to do exactly. So when I talk about the word called as program, so it's a list of instructions. So you have told the computer what exactly needs to be done, in what order, and what is your basic set of instructions, your basic commands to the computer. The documentation is a source of information about the product contained in design documents, the detailed codes and comments. So when I talk about documentation, the word immediately gets onto an enlarged, extended file altogether, which will have a set of instruction, set of complete manuals and tasks that needs to be done by the computer over a given period of time. Now, the operating procedure, step-by-step instructions compiled by another organization to help carry out the worker's complex routine operations. So when I talk about operating procedure, it is different from documentation and program. Why? Because operating procedure is the step-by-step guide that a person needs to do when it comes to execution of the program. The first two are the theoretical instructions that we are just laying down the foundation towards the development of software model. But in the third step, when we are talking about operating module, that means to say that that's the step-by-step guide which tells you what exactly needs to be done by the worker, by the person who is handling that program. Followed by which the other software components, we are going to talk about the code, then the data, the user, libraries, and the documentation. Now let's go one by one here. When I'm going to talk about code. Code is the set of instructions that a computer executes to perform a specific task or set of tasks. So that means when I want a specific task to be achieved, a specific level of work to be achieved by the computer, I'm going to go on to the code because coding becomes very, very important. The data is the basic thing on which the software would try to manipulate. When I'm using the word manipulate, I'm not trying to make it other way around. I'm trying to say that we are going to work on the data. Now, the second thing here is that the user means the person who's going to interact with the software. The user is going to be the key personality because he is going to have a constant interaction. He's going to be in touch with the software in terms of the working part, and he's going to be the person who's going to see where the menus, where the buttons, what is the system all about. Followed by the libraries. Now, when I talk about libraries, pre-written code that can be reused by the software. Now, when you talk about Java, Java has a set of library functions. This is also found in C++ also. When I say the word library, that means to say that pre-written codes are already available for a user and he can call for the functions at any point in the program. So what is the importance of having library? You don't have to waste time again writing that code, again writing that entire program. You can just call for the function and you would be able to complete the task much ahead of time. Followed by documentation, information that explains how to use and maintain the software, such as user manual and technical guides. Now, this user manual, technical guides are certain things which are of high importance to anybody in this world. Why? Because that is going to tell exactly how and where are the do's and don'ts that are available for a software developer today. Followed by which the key process activities. Let us start with software specifications. What are the specifications in this process? A detailed description of the software system is to be developed, that is given, and with the non-functional factors. Now we talk about software development. In this process, designing, programming, documenting, testing comes into picture. And finally, we are going to talk about validation, where the evaluation of the product is done to ensure so that it meets the standards and the requirements of the user. So let us now first try to understand specifications very clearly. Specification is something where you are going to direct in terms of functional and non-functional activity. So whenever you're going to build a building or you're going to build a house, you have certain set of specifications. That includes the design, that includes how the house needs to appear, how it needs to look, what kind of rooms, what kind of hall and everything. So similarly, a software will also have certain specifications which are clearly laid down from the business analyst standpoint, from the client standpoint, saying that this is how exactly the software needs to work. So when you again bring it down from a technical analysis standpoint, the understanding should be in such a way that you are able to address the functionality as well as the non-functional points so that you are able to get exactly what your customer wants. Next is the software development. Once your specifications are done, you start working towards the specification by designing, coding, programming it, and then testing, debugging, and you're going to the next level, which means based on the specifications comes the software development. So you're taking it to the next level in terms of addressing the entire software process. Next comes the validation, which is very, very important. Why do you validate a software? If you ask me this question, the answer to that is validation is the last and the most important step which will make you understand, am I meeting the specifications set by my client clearly? Now, whenever you complete a task, we always go back and check whether we have completed the task as it has been prescribed. So this is something like a prescription altogether. So at the end of the day, you need to see that whether the software meets the needs of the user. Suppose it does not meet. Suppose there is a problem in terms of functioning. There is somewhere a problem where error is coming in. That means we have not completed the development process. This will again go back to a step where we need to check and where we need to come back. So until a product is validated, we have not completed the software process. Let's go further and try to understand how exactly this process model comes into picture. Now, this is where we are going to define a simplified representation of software process, each process from a specific perspective. Now, that's very, very important. Why are we designing a software process? Because we have something specific. We have some purpose for which this entire model is built. So that's why we get into this process altogether. Following from which some basic software process which are different is a workflow model. In this, it's a sequential series of tasks. So you will go one by one trying to address the entire business process. The waterfall model, as we were speaking about, which is a linear and sequential flow. And then we start getting into the phases of the waterfall model, as I was talking about: requirement, the software design, then you implement that software, then you test it, and then finally you come to the data flow model altogether. Now, the data flow model is one which talks about where exactly the data gets exchanged, the flow of the data, the flow of the entire art of communication that starts moving between the systems. So the entire information flow is addressed within that particular system. Now, we also need to understand the need for a process model. Why? Because this is necessary, because the software product development can be done systematically. Many a times what happens in a company is that they know that they are doing something new for the customer. They are excited about a project, but what exactly misses is the methodology. If you miss out on a methodology, you will not be able to arrive at a conclusion. So software process model is something which needs to be addressed systematically with understanding each and every step. You need to know the activities that are involved, how they are connected, how they are going to deliver the results, and how there is a discipline in terms of understanding that sequential flow or the process. So over a period of time, you would start understanding that the transition of a model to that of a live product that's going to reach to the hands of the consumer really matters. And that is possible only through the various steps that we have taken here. So every company needs to understand that when they are developing a software model, there are some steps that needs to be understood, that needs to be published, that needs to be told to the client clearly that this is the model on which we are building your software. So in case if there are any doubts, if there are any challenges, we can always go back, readdress the issue, and make the best software product available. Now, the advantages and disadvantages are there. Always whenever we talk about a process and model, there are always some advantages and disadvantages. Like the advantage of a waterfall model, as we are talking about, it has got a clear and defined phase. So it's very easy to implement. It is well suited for projects with well-defined and unchanging requirements. So if you're going to look into a single model-based project where there's no much of multiple requests or command, then the waterfall model is the best, because you can go step by step, achieve the task, and then you can take it forward. But on the other side, when you look at the disadvantages, it can be very, very difficult where the change requirements have to be made. And the problem here is that it takes time, because it's going on a linear sequential flow. It moves from one point to another, and there is no much room for iteration and feedback, because the waterfall model is more considered about the flow rather than the changes coming into picture. Now, similarly, when you look into the agile method, yes, agile is one thing which will talk about the emphasis of rapid prototyping, continuous delivery. It encourages collaboration. These are some of the advantages that we are looking in. But then when you look at the disadvantages also, it's difficult to plan and manage. We also talk about certain factors where, we are not able to deliver the well advanced models. It can be difficult to estimate the overall time and cost of a project, which is very important in the modern days. Why? Because if the cost increases or the time factor increases, then automatically the client is going to get worried, because they would have agreed for certain terms and conditions. In all of a sudden, if you're going to raise the budget, you're going to raise the entire phenomenon there, then the software process model can take for a toss. Now, the conclusion on the software process is that it provides a very, very structured method for developing and maintaining the software. There are approaches like Waterfall, linear projects, agile, flexibility, the Scrum for teamwork and DevOps. All these things actually matters a lot for us, and each one of them have a unique strength tailored to a different project, different needs altogether. Now, choosing the right process enhances our efficiency, no doubt about it, and also the product quality. So keeping all this in mind, we are actually trying to build the most structured software development process which can address the modern needs for this world. With this, I come to the end of this particular session. I hope and believe that all the facts and figures that we have spoken here would be of a great help to you, both in terms of theory as well as in the practical walk of life. In the upcoming classes, we are going to talk more about the software process models in terms of development ethics and how we are going to take forward these classes. But until then, stay tuned and stay blessed. Thank you once again for joining me today on this wonderful session.